Okay, this is the P3 paper from January 2023. We're actually going to be looking at question number 1 here, which is a functions and graphs question. We've got that fx is defined as being 9 minus x squared. Keep an eye on the domain there. Gx is defined like that. Again, keep an eye on the domain there as well. Part A says, can we write down the range of f? Well, when I'm in my teacher mode and I'm asking any of them to work out the range, I always say, can you quickly sketch it? And we certainly can for 9 minus x squared. I would expect all of you to be able to know that minus x squared looks like that. So 9 minus x squared is looking like that with a maximum value there of 9. So that's more than enough information. Just be aware again that the domain is x greater than or equal to 0. So if that's the situation, then the range is going to be the limitations on y here, and the limitations on y are simply going to be that fx has to be less than or equal to 9. So only 1 mark, but it's very, very easy, that part. Part B talks about the composite function fg 1.5. So just a reminder to you, fgx, what that actually means is do gx first, get the answer, and then do f to that. We're reading that way when we read a composite function. So here, if we're doing fg 1.5, actually what I'm going to start off is g 1.5. So that's putting 1.5 into g. Remember 3 over 2x plus 1. So that works out to be equal to 3/4. So fg 1.5 is f of 3/4. And f of 3/4 is putting 3/4 into the function 9 minus x squared. So 9 minus 3/4 squared. And that works out to be apparently 135 over 16. Okay, on to part C. Part C is the inverse of g. So if we've got g here, in order to work out the inverse, we need to just set it as y equals and then rearrange. Be aware of the fact that we will need to state what the domain is. So if g is equal to 3 over 2x plus 1, then we set, as I said, y is equal to that, and now just rearrange and make x the subject. So multiply both sides by 2x plus 1. Multiply out that bracket. Take the y to the other side, and then divide by the 2y. So I've got that the inverse function then, we don't have y's in our answer, is 3 minus x over 2x, but I do need to say what the domain of it is, and the domain will come from the range of this one here. Now, I've spent previous videos going through a lot of detail of the range of these things. So range of 3 over 2x plus 1. Well, we can see really, really quickly, because obviously I've done this before, but just take a little bit more time over this if it's worth more marks. If I'm trying to sketch this function, I can see that 2x plus 1 equals 0 is going to give me x equals minus a half. So that's going to be the asymptote going that way. And obviously the other asymptote is going to be here at y equals 0. So those are my two asymptotes. And if we put x equals 0 in, then we get 3 over 1. We get the value 3 there. So that means I know that this graph would do that and that. And what I'm interested in, say if that value there is 3, I'm interested in when x is greater than or equal to 0. So the range of this original one, way too much time on this, but the range of the original one would have been fx or gx, can't remember which one it is, gx, sorry, is between 0 and 3. Now it is equal to 3, it's not equal to 0 because obviously it's an asymptote there. So going back up to here, the domain then would be that. Now I wouldn't necessarily have that on my answer, that was more for teaching for you guys, but I want to make it really clear where my actual answers are, which is over there, that one, that's the last part of that. Okay, so a little bit of teaching involved in that as well, but hopefully the final answer makes sense.